So hello students, welcome to the online lecture series for RCC. The topic for today's lecture is design of column. So as we've already studied that column is a compression member and it is a vertical member too. So now we will proceed for the design of column. So for the design of column there are certain steps. The first step is to find out the effective length of the column, which also depends on the slenderness ratio. So effective length is denoted by L effective. So it is the length of column which take parts in buckling. Means the length which will take part in buckling or which will take part in the deformation, or it is the distance between points of zero moment, which is also known as point of contraflexure. So as you can see from this figure that the overall length of this column is L, but the effective length is L effective, it is only this much. So it is L effective is always shorter than the overall length because it is the length which will take part in buckling or in deformation. So in this figure you can find out the point where there is zero moment or where the sign convention of moment changes. So effective length depends upon the support conditions. So there are some support condition given here, and according to that L effective is given, and L effective is given in two parts. First is theoretically and another one is IS 456 part. So we will always take from IS 456. So if both ends are fixed, like you can see from this figure, both ends are fixed, so L effective becomes, according to theoretical, L by 2, or you can say 0.5 L, but from IS code it becomes 0.65 L. So you will always take the value of IS code because we are following IS 456. Another condition is when one end is fixed and another is hinged. So one end is fixed, another is hinged. So in this case L effective theoretically becomes 0.707 L and L effective from IS code becomes 0.80 L. Third condition is if both ends are hinged. So here L is same for both theoretical and IS code, so it becomes single unit, that is L. And last one is if one end is fixed and another end is free or roller. So it is free, fixed and free, and roller and fixed. So in this case again the IS code values and theoretical values for L effective become same, that is 2L and 2L. Now we come to the part of reinforcement in column. So how much reinforcement we have to provide in column. So reinforcement in column are of two types. First one is the main or longitudinal reinforcement and another one is the transverse reinforcement. In case of beams we know it as main reinforcement and stirrups, but in case of column the main reinforcement is also known as longitudinal reinforcement. So here reinforcement in column is provided to, first point is it is provided to reduce the cross-sectional area of concrete and to reduce its heavier cross-section. So it counteracts to the weight of the concrete which is used in column. So it is firstly used to reduce the cross-sectional area, because if we will provide less steel then we have to provide more concrete to counteract the strength. Second part is to take care of tensile stresses due to eccentricity. So we have already studied the term eccentricity here. So eccentricity is when the load are towards the CG. So it takes care of the tensile stresses due to eccentricity. Third part is to impart ductility in column. So you can see that column generally happens to be buckled up, so it imparts ductility to the column, means it will not break suddenly, it will have a warning. And last point is to take care of creep and shrinkage effect in compression, because as you know that concrete is more vulnerable to creep and shrinkage. So by providing steel we take care of that creep and shrinkage effect, we lower down the impacts. So according to IS code 456, which we are using for design part, the minimum dia of column bar is 12 mm. So means you have to provide minimum 12 mm dia for the main reinforcement in column, and minimum area of reinforcement, which is known as ASC. Here ASC is the area of steel in compression, because it is the steel which is having or facing the compression part. So ASC minimum is 0.8% of gross area. So it is very important to be remembered that the minimum area of reinforcement provided in column is 0.8% of the gross area. So it becomes 0.008 B into D. Here B into D is the cross section area. Now we comes out to the higher value. So what is the maximum area of steel in column? So it is again important part. So ASC max is 6% of the total gross area. So here ASC max becomes 0.06 BD. So ASC minimum is 0.8% and ASC maximum is 6%. So you have to remember this range for column. Okay. Again, there are some points that minimum number of bars in rectangular or square column is 4. So you have to provide minimum 4 number of main bars in a rectangular or square column. For circular column, it becomes up to 6, and maximum spacing of main bar in a column should not be more than 300 mm. So it is again defined here, the maximum spacing of main bar in column should not be more than 300 mm. Okay. So you have to provide the minimum spacing, or in this case we have provided you the maximum spacing. Also the minimum area of steel for pedestal is taken as 0.15% of gross area. So I have already told you that what is a pedestal. It is the component of a truss. So for pedestal we have to use minimum area of steel as 0.15% of gross area. Now comes to the clear cover part. So what is the value of clear cover that we have to provide it in column? So the minimum clear cover is 40 mm or dia of the largest bar. So whichever is maximum from these two values, we will provide that value for minimum clear cover. So minimum cover, clear cover for column is 40 mm or dia of largest bar, whichever is maximum between these two. So there is a note, if maximum dimension of column is limited, because we have to take care of the size also, so we will restrict the dimension of the members. So in case of column we will restrict its maximum dimension. So if the maximum dimension of column is limited to 200 mm, then the clear cover is reduced to 25 mm. So in this case, only in this case, if the maximum dimension is around 200 mm, so we will provide a clear cover to 25 mm. We will not consider this value. So it is an exception here. So it is mentioned here that this column is having a dimension of 200 into 200. So it is a square column. So we will provide 25 mm clear cover, and the minimum number of steel bars are 4. You can see from here 1, 2, 3, 4. So all the conditions are satisfied here. Now second one is the transfer reinforcement. So transfer reinforcement is generally like the vertical stirrups that we were providing in beams. So in case of column, it is known as transverse reinforcement. So it is an important point here that it is provided to resist the lateral movement of main bar and keep it in proper position. So like we were using the stirrups, similarly this transfer reinforcement is provided for the column. So its main role is to resist the lateral movement of main bar and keep it in its proper position. Also it is made up of steel, so it will impart some ductility also. So these are provided in two forms. First one is lateral ties and second one is helical reinforcement or spiral. So lateral ties is generally provided for rectangular and square column, and helical reinforcement or spirals are provided in circular columns. It is very easy to remember. So first one is the lateral ties. So for lateral ties, the diameter of ties we have certain range from IS code. So diameter of ties is 6 mm or 1/4 of largest dia of main bar. So whichever is maximum in these two, we will take as the diameter of ties. Okay, so suppose we are using 8 mm dia or 12 mm dia for the main bar. So 12/4 becomes 3 and we have provided 6. So 6 and 3, 6 is maximum. So we will take the diameter of ties as 6 mm. So it will depend on these two factors. Suddenly the pitch or spacing means it is like transfer reinforcement provided like this and main reinforcement provided like this. So the pitch is this, which is also known as spacing between two transverse reinforcement. So it will depend on three factors. First one is the least lateral dimension, means if it is a square column, so you can take either of the dimension, but if it is a rectangular column, you will take the smallest value of the dimension part. So least lateral dimension 300 mm or 16 times the dia of smallest main bar. So you can say it 16D minimum. So it is the diameter of minimum bar. So you will take 60 dm. So whichever is minimum between these three, you will take it as spacing. So as you can see that spacing is provided for the minimum value and diameter of ties is taken as for maximum value. So you have to remember these points. It will be very helpful in designing the column. Second type of transfer reinforcement is helical reinforcement or spirals. So it is, as we have already told you, that it is generally provided in circular column, and also you know that the minimum number of bars for circular column is 6. Okay, so you have to remember this also. So load carrying capacity of column with helical reinforcement is increased by 5%. So while we are providing helical reinforcement in the circular column, it load bearing capacity will increase to 5%. So you must be seeing that in the major building structures or bridges we are providing circular columns or circular piles or piers. So it is provided because it is having more capacity of carrying load. Now the dia of helical bar or helix or spiral, whichever we are using in circular part, so it depends on two factors. Either it is 6 mm or 1/4 of dia of largest main bar, whichever is maximum. So as we have already discussed for the transfer reinforcement part, that the dia will be taken from maximum value and pitch will be taken from minimum value. So dia of helical bar will depend on 6 mm or 1/4 of dia of largest main bar. So whichever is maximum we will take as dia of helical, and pitch or spacing for this helical reinforcement is taken from 75 mm to 1.6 dia of core. Okay, so dia of core means if this is a circular column and this is the helical reinforcement part, so this is the dia of core. So 1/6 of dia of core, whichever is minimum between these two, we will take it as the pitch or spacing. Okay, so pitch or spacing also depend on the maximum part also. So there is another condition, 3 times the dia of helix or 25 mm, whichever is maximum. So in case that if dia of core is not given, you can use this formula, but if dia of core is given, you can easily use this one. Okay, so here is the figure given. So dia of core, as I have already told you, that number of minimum bars used in a circular column is 6. So 1, 2, 3, 4, 5, 6. It is a minimum. You can use more, 8 also. It will come as per the design, but you have to use minimum 6 bars. This is a dia of core. It is the clear cover. This is the overall dia of the column, circular column. So in this case, this is the helical or spiral reinforcement. So it is the pitch. To upward part or crest of the helical reinforcement, it is distance vertical distance between this, the pitch should be not be greater than 75 mm and should not be less than 25 mm. So it is the range from this part. Okay, so as we will move forward, we have to check for the eccentricity part also, because it should have a minimum eccentricity. So minimum eccentricity in column according to IS 456 code is E minimum depends on two parts. E minimum is easily calculated from the formula unsupported length upon 500 plus least lateral dimension by 30. So we'll get a value from here. Another one is 20 mm. Whichever is maximum between these two, you will take as E minimum. Okay. So now the load carrying capacity of short column, because we are designing for short and long column, we've already defined that what is a short and long column. So for short column, the condition is that if L effective by least lateral dimension, in case we are taking it as B, it is less than or equal to 12, then it is known as a short column. And axially loaded columns, E minimum should be less than equal to 0.05 least lateral dimension. So we have summarized this as E minimum should be less than equal to 0.05 D. So for axially loaded, this condition should be satisfied. And third, for long column, you know the condition that L effective by B is greater than 12. So while designing, because we are designing this whole part from LSM, that is limit state method, we have to use certain formula. So we have formula for the factored load, that is PU, the load coming on the column, is calculated by these different formulas, and these different formulas are for different types of loading and columns. So for short axially loaded column with lateral ties, so if we are using a short column which is axially loaded and it is having a lateral tie, means it is a square or a rectangular column, then the load PU will be calculated by the formula 0.4 FCK AC plus 0.67 FY ASC. Here FCK is the characteristic compressive strength of concrete which we are using. AC is the area of concrete. Again, FY is the strength for steel or the grade of steel which we are using, and ASC is the area of steel in compression. So this formula will apply for short axially loaded column with lateral ties, means it is a short column, it is axially loaded, means E minimum condition is being satisfied, and it is having a lateral ties, means it is a rectangular or a square column. Now for again condition we have changed. Now condition is that it is a short axially loaded column with helical reinforcement, means it is a short column, it is axially loaded, means it is satisfying the condition of E minimum, but in this case the shape has been changed. The shape is circular because we are using helical reinforcement. So here the load will be calculated by formula PU equals to 1.05 and the value remains same. So you can easily summarize it as that the short axially loaded column with helical reinforcement is 1.05 times the short axially loaded columns with lateral ties. So this value is same for both. So you can easily make a relation between this. Now third one is that if it is a long column, now the condition has been changed, it is a long column with lateral ties, means it is a long column having shape as rectangular or square. Okay, so PU will be calculated by CR multiplied by 0.4 FCK AC plus 0.67 FY ASC. So this whole terms remain same for generally all types of loading and all types of columns, but the condition apart from this bracket changes. So CR is the reduction factor here. So okay, it is a reduction factor of strength. So generally it is the ratio of yield stress or elastic strength to the yield strength. Okay, so you can easily check it out from the IS code and from your books also. So PU becomes CR times 0.4 FCK AC plus 0.67 FY AC. So this condition is long column with lateral ties. Now last condition will be long column with helical reinforcement, means it is a long column but it is a circular column too. So the PU becomes 1.05 CR multiplied by 0.4 FCKAC and 0.67 FYASC. So there is a relation between C and D also. So the long column with helical reinforcement is 1.05 times the value of long column with lateral ties. So you can see that the helical reinforcement is having much value of load than the lateral ties or rectangular or square column. So you can easily make a relation between. So here the PU is the ultimate load carrying capacity of the column. So while designing, we have to calculate the maximum value of the load carrying capacity. FCK is the characteristic strength of concrete. Fy is the yield stress of steel, which you can easily calculate from the grade. AC is the area of compression steel, and CR is the reduction factor. So from these values you can easily design a column. So that's all for today. Thank you.